Okay, hello everyone. So here I have some basic trigonometry review, just basically tailored to what you're gonna need for this year. Okay. All right. So let's go ahead and get started. We're gonna start with the special right triangles. So you guys know that. Sorry. We have two special right triangles, and the first is a 30, 60, 90, and the other one is a 45, 45, 90. So for the 30, 60, 90, you've got two acute angles. That's the 30 and the 60. And notice those are not the same size, right? You've got a small angle and you've got a larger angle. And the small angle faces the small leg. The large angle is opposite the large leg, right? And when we labeled special right triangles, we always started with the small leg, and if that's a 1, then the larger leg is √3, and then the hypotenuse is always 2, right? We know this, 1, √3, and 2. Okay. In a 45, 45, 90, we've got angles of the same size, acute angles of the same size, legs of the same size. So if we label the legs 1 and 1, then the hypotenuse is √2. Okay, that's all fine until we get to the unit circle. And in order for us to be able to use these in the unit circle, we have to rescale the triangles so that the hypotenuse is a length of 1 only. So in this triangle on the top left, if I want to make the hypotenuse a 1, I have to divide that by 2. Then I have to do the same thing proportionally to all the other sides, divide them each by 2. So then the new side lengths of the 30, 60, 90 triangle become a 1 for the hypotenuse, a 1/2 for the short leg, and a √3/2 for the long leg. And all you need to know right now is that the short leg is 1/2 and it faces the 30-degree angle. The long leg is √3/2 and it faces the 60-degree angle. That is really all you need to know. Okay, so from that now, if I were to ask you, let's say, what is the sine of 30 degrees, right? So remember, we had SOHCAHTOA, right? Once the hypotenuse becomes 1, right, dividing by the hypotenuse, opposite over hypotenuse, is now meaningless because the hypotenuse is always 1, right? So I could pretty much ignore the h's in there. So now sine is just the opposite. So if I want sine of 30, it's just the opposite, 1/2. If I want the cosine of 60, right, it's just the adjacent to the 60, 1/2. And then if I want the tangent, let's say, of 30, that's still the opposite over the adjacent, and that's 1/√3. Okay, so now moving on to the 45, 45, 90. That had a hypotenuse of √2. If I want to make that hypotenuse a 1, I would have to divide by √2, right? So that means the hypotenuse of that becomes a 1, and then each of the legs will be 1/√2. So again, if the angle is 45 degrees, the opposite, which is sine, is 1/2, The adjacent, which is cosine, is 1/2. The tangent is opposite over adjacent, which is 1. Okay, so here are some more triangles. Let's move past to the unit circle. The unit circle is basically a circle with a radius of 1 centered at the origin, right? This is pretty much it. So if I have the x and y axes, this is 1, 1, -1, -1. And now if I were to draw a circle around it, oh my God, that is a unit circle. That's all a unit circle is. Okay, now here is a unit circle that's drawn at a much bigger size. So let's see what some of the angles are, right? You know the degree equivalents that go around this. This is 0 degrees, and then we have 30, 45, 60, and so on. Okay, so this first, what do you call it? Let's do the quadrantal angles here first. So here we have 0 degrees. At the top, now from 0, I've gone 90 degrees up, and that's pi over 2. This one is pi. And then on the bottom here is pi and then another half, so 1.5 pi, which I write as 3 over 2 pi, or 3 pi over 2, and then I get back to 2 pi. Fabulous. The first marking here is equivalent to the 30 degree, which in radian is pi over 6. Okay? Now, how do we know that? Well, 30 degrees, right? How do you get 30 degrees from 180? You would do 180 divided by 6. Well, what's 180? It's pi over 6. That's how you get 30. Okay, moving on. So that's the pi over 6. That's the first line away from the x-axis. And here the first line away from the x-axis is this one. First line away from the x-axis is this one. And then also this one. Right, so let's get rid of this mess. If the first one is pi over 6, now I'm going to add coefficients to pi over 6. We've done this before. And I'm going to stop at the coefficient which does not cancel or reduce with the 6. So 1 pi over 6 works. 2 pi over 6 is no good because the 2 and the 6 reduce, so the 6 goes away and becomes a 3, so that's no good. 3 pi over 6 has the same situation. 4 pi over 6 is the same. 5 pi over 6 never reduces, and the 6 stays at the bottom infinitely. Next one, 6 pi over 6 doesn't work, but 7 pi over 6 will work. And then we go through the coefficients, 8, 9, 10 pi over 6. 11 pi over 6 is the next one. So notice in each of these, the denominator is a 6, and that visibly stayed the whole time. Okay, so next. Next, let's do the pi over 3, right? So those are these ones. Oh my, that's my dryer going. So all of the ones that correspond to the pi over 3, right, are the same distance away from the x-axis, right? Okay, so that's pi over 3, 1 pi over 3. 2 pi over 3 is the one that goes here because the coefficient of 2 does not reduce with the 3 and the 3 stays. 3 pi over 3 does not work, but 4 pi over 3 works. And so does 5 pi over 3. Again, I think we've, I'm sure you remember we've done this at the beginning of the year. Next, we're going to do the pi over 4s. Those are this one. That's equivalent to 45 degrees, right? Pi over 4. 2 pi over 4 doesn't work, but 3 pi over 4 does. 5 pi over 4, 7 pi over 4. Now for calculus, you don't need all of this. All you need really is the first quadrant and then the 0, pi over 2, pi, and so on. Okay. So here I talked about rescaling the triangles so that they have a hypotenuse of 1, right? Okay, so why did we do that? Why do we even care about having a hypotenuse of 1? Well, take a look. Remember I said the unit circle is a circle with a radius of 1? So if you look at this, each of these are radii of 1, right? And so now if I wanted to fit a triangle in here, the triangle can only be situated in a way that the hypotenuse will align with one of those lines. Okay, what are you talking about, Miss Malikian? Well, let me tell you. I have 3 triangles here. These are not random triangles. This first, this middle one here has a 30-degree angle. Okay, 30 degrees, 60 degrees up here, and so on, right? But this bottom left angle is 30 degrees. So now take a look at what I'm going to do. I'm going to take that 30-degree triangle and I'm going to fit it inside of my unit circle. So that comes right over here. And do you see when I put it in there, how the hypotenuse of the triangle is the same as the radius of the circle, right? That's why I needed for that hypotenuse to be a 1. And so now, how big are the sides of that triangle? Well, this is the short leg of a half, and this is the long leg of √3/2. And remember that corresponds to the angle pi over 6. So now, if I want to find the sine of pi over 6, well, that's the angle, right? That's pi over 6. The opposite to that is 1/2. So that is the sine 1/2. Another way to look at this, right? Another way to look at this is if you do have a pi over 6 angle, that will intercept the circle, the unit circle at this point. You can't really see that. It will intercept the unit circle at this point. So now, how does one get to that point? Well, to get to that point, I have to go horizontally a little bit and over a little bit. Well, if that's a 30, 60, 90 triangle, there are only 2 possible sides that I can travel. A side of √3/2 and a side of 1/2. So to get to that pi over 6, how do I go there? Because that's the pi over 6 angle, I travel horizontally much longer than I go vertically. So that horizontal side, which is the adjacent to the angle, and it's the cosine, is always √3/2. And the opposite side, the vertical side, which is always opposite to that angle, is 1/2. So that's pretty much how that works. Okay, so now, if I continue along with this triangle on the top to the right has a 60-degree angle. If I were to take that triangle, and if I were to move it down here, look, that corresponds perfectly with that pi over 3, right? So now, if I had a pi over 3 angle, and I want it to go to the point where the pi over 3 intercepts the circle, how do I get there? Well, I have to go horizontally a little bit and vertically a little bit. The pi over 3, the 60-degree, that's my larger angle. So I have to go up much higher than I have to go over horizontally. That means the horizontal distance is the short distance of a half, and this is √3/2. And since sine is always the opposite, sine of 60 is going to be √3/2. Cosine of 60 is always going to be a half. And you can do the same exact thing with the 45-90 triangle, right? It's got to have a hypotenuse of 1 in order for it to fit into that. And now you can see, in order to get to the pi over 4 angle, right, where the pi over 4 angle intercepts the circle, you have to go horizontally a little bit and up a little bit. But in the case of the pi over 4, the horizontal distance and the vertical distance that you go are identical. They're the same. And so for each way, you travel 1 over √2. Okay, I mean, I can talk about this until, tomorrow night. But I think let's stop there and let's move past this. Okay, so depending on which of these quadrants your angle falls in, right? So if you have a 45-degree angle or a 120-degree angle and so on, the trig functions can take on different signs, like plus or minus signs, right? And for that, you know, we have this acronym. I don't normally like mnemonics, right? But this is the one case where it's okay. So it's all students take calculus. And where you have A, it means all the functions are positive. Sine is positive, cosine, tangent, they're all positive. In the next one with the S, only sine is positive and everything else is negative, right? And then here, tangent is positive and then cosine is positive. Okay, fine. Let's do some actual examples now. I need to find cosine of pi over 3. Okay, so here, we're going to go here. Cosine of pi over 3. Pi over 3 is this one. How do I get to this? Okay, how do I get to that point? I have to go horizontally and vertically. Cosine is always horizontal. So to get to that point of interception, the horizontal distance is the smaller distance for the pi over 3. That's a half. And so cosine of pi over 3 is 1/2. If you like, you can draw yourself a rescaled triangle with pi over 3. The sides for that are √3/2 and 1/2. Cosine is always the adjacent, so it's 1/2. Okay, sine of 30. 30 degrees is here. I'll do that in green. Sine is the opposite, right? So between the vertical and the horizontal distance, right? Sine is the short one of 1/2. So sine of 30 is 1/2. Again, if you want to draw yourself a triangle with pi over 6 or 30 degrees, now the sides are switched, right? Short is facing the small side. Sine is the opposite, 1/2. Okay, cosine of pi over 4, again going with the triangles for the pi over 4. It's 1/√2, 1/√2. So that's 1/√2. Okay, tangent of pi over 6. Where is my pi over 6? This is the triangle. Tangent is the opposite over the adjacent. The 2's cancel, so I have 1/√3. All right, moving on. Quadrantal angles. Okay, first of all, what is a quadrantal angle? When the terminal side of an angle falls on the x-axis or the y-axis, it's called a quadrantal angle. Okay, so these are the quadrantal angles. 0, pi over 2, right? You see the angle, that's pi over 2. Pi, 3 pi over 2. So it falls basically on the axes. Okay. Now, to find trig functions, we're just going to use the corner points, right? Remember, this is where the circle would have gone, right? That's a horrible circle. But that's pretty much what you're going to use for your quadrantal angles. All right, so let's use these circles. All right, so what are the angles here? The angles are 0, pi over 2, pi, 3 pi over 2. Okay, so remember how we said for each angle, the sine and the cosine are basically where the angle intercepts the circle, right? So for the 0 degrees, this is where it intercepts the circle at that point right there. So how do you go there? How much do you go horizontally and how much do you go vertically? Well, horizontally, I go over 1 unit. Vertically, I don't go over at all. 0, right? So that's what these represent. Horizontally, you go over 1. Vertically, you go over 0. So let me just look horizontally and vertically. So remember what we did here, right? I just want to show you how consistent this all is. Horizontal and vertical. The horizontal distance was always the cosine, and this vertical was always the sine. So now if I go up here, the horizontal is always the cosine, and the vertical is always the sine. So for each of these are the cosine and the sine values. Let's try with the pi over 2. Right? To get to the pi over 2, to get to where the pi over 2 intercepts the circle, how do I go there? Well, I go horizontally 0, so that's cosine. Vertically 1, so that's sine, right? And so similarly, right, each of these is cosine, sine, cosine, sine. Okay, so here's how I do these, right? So take a look at these. I have 0 degrees and I want to find sine of 0. Okay, sine is the vertical distance. So I ask myself to go to the 0 degrees, which is here. Sine is the vertical. How much do I go vertically? 0. So sine of 0 is 0. Okay, cosine. Cosine is the horizontal. So to get to this point, how much do I go horizontally? Positive 1. Tangent is the sine over the cosine, 0. All right? Okay, let's move on to the 90 degrees. And we'll do the rest later. 90 degrees is here. So to go from the origin to that 90 degrees up here, how much do I go vertically? That's the sine. Vertically, I go up 1, so positive 1. Cosine is the horizontal. How much do I go horizontally to go up to the 90? 0. Tangent is 1 over 0, undefined. Right, so let's go to the 180 here. To get to that point from the origin, right? Sine is vertical. How much do I go vertically to go to that green point? 0. Okay, how much do I go horizontally to get to the green point? Left 1, which is negative 1. Tangent is 0 over negative 1, 0. Okay, lastly for the 270. Okay, how do I go there? How much do I go vertically? Negative 1. How much do I go horizontally? 0. Tangent is undefined. Okay? And then for each of these, right, cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So that's how you do them, right? And then you can do it like for anything you want. So negative 180. Negative 180, right? If I start here, negative 180 is here. Well, how do I get from the origin to that point? I want sine, right? Sine is the vertical. How much vertically do I go to get to that point? 0. Okay? All right, negative pi over 2. Where is negative pi over 2? I start here. I go this way to pi over 2 right there. So now here's the question. To get to that point, sine is the vertical distance. How much do I go vertically from the origin to that point? Down 1. So that's negative 1. Okay. Let's move on to inverse trig functions. Okay. So basically the inverse trig functions are inverse sine x like this, inverse cosine x, inverse tangent x. And by the way, they can also be written as arc sine, arc cosine, arc tangent. They're synonyms, right? There's no difference between them. Right. These functions now go in reverse order. So until now, you were given the angle, you needed the value. Now it's going to go in the opposite direction. You're going to be given the value and you need to find the angle, right? So for example, until now we've been doing this, sine of pi over 6. Well, we did it a couple pages ago. We said it was 1/2. So now let's go the other way. Suppose you were given this. Inverse sine of 1/2 is what? So this is telling you what angle gives you a sine of 1/2. What angle gives you a sine of 1/2? So if you go back to the triangles, what angle gives you a sine of 1/2? Remember, sine is always the vertical side, right? What angle gave you that? That was pi over 6, right? So we're actually literally going in the opposite direction. So the answer here is an angle pi over 6. Okay, however, inverse trig functions have a story, right? We talked about this a little bit in class, that in order for something to have an inverse function, it has to pass the horizontal line test. Sine, as it stands, does not pass the horizontal line test. If I draw a horizontal line through it, it should only pass the graph at one point, but you see that fails. So what we do is we restrict the domain of the sine, and we only take one itty-bitty portion so that it does pass the horizontal line test. The portion that we restrict it to is from negative pi over 2 to pi over 2. So let's just summarize that. Here is how inverse sine of x is written. Y, which is basically the answer, is always the angle. Pi over 3, pi over 4, pi over 6, pi, 0. And then x is the number here. It must always be between -1 and 1. So that's extra information. We're not really going to run into that. Okay. So remember how we said we restrict the domain from negative pi over 2 to pi over 2? Okay. Take a look at this unit circle. The blue is the only part where our inverse sine exists. So where is negative pi over 2? Down here. Where is pi over 2? Up here. So it's only this region that we care about. 0 is here. Right, so what other angles are over here? Well, it's the same players of the game, right? Pi over 6, pi over 4, pi over 3. And then here, negative pi over 6, negative pi over 4, negative pi over 3. Okay, now, if x is positive, remember x is the number in here. If x is positive, the angle can only be from quadrant 1, here. If x is negative, it could only be in quadrant 4, here. And so if we have an angle in quadrant 4, it's only got to be negative pi over 6, negative pi over 4, and so on, right? Take a look at this angle here. You see how 5 pi over 3 is in quadrant 4 on the actual unit circle? But 5 pi over 3 doesn't exist here. So that can never be an answer. Your answers for inverse sine can only be one of these 9 angles. So let's see what we can do with these. Find the exact value of each expression if it exists. Okay, inverse sine of 1 over root 2, right? So here you're looking for the angle, the sine of which is 1 over root 2. So if you want to go back to your rescaled triangles, you can do that. Remember, we want inverse sine, right? Sine was the vertical side. Which of these three angles has a vertical side of root 2 over 2 or 1 over root 2? That's this one. So that's pi over 4. Okay, now you're telling me, no, on the triangle, the side was 1 over root 2. Now you're telling me root 2 over 2. But if you rationalize, this is root 2 over 2. Okay, now we want inverse sine of negative root 3 over 2. Okay, let's ignore the negative for a minute. For what angle is sine root 3 over 2? Well, go back and take a look at the triangles. The opposite side of pi over 3 is root 3 over 2. Fine. But this is a negative, guys. It's got to be from the negative quadrant. What's analogous to pi over 3 in the negative quadrant? Negative pi over 3. Okay. Here, I want inverse sine of 1. Can I get a sine of 1 from any of the triangles? No, none of the triangles have a vertical side of 1 after we rescaled them, okay? After we rescaled them. So that means I gotta go to my quadrantal angles. And look, basically, which one of these have a sine of 1? Well, that's the pi over 2. So this is pi over 2. Okay, let's do cosine. Cosine's restriction goes from 0 to pi. So that's how that looks. 0 to pi. This is pi over 2. And the angles are as follows. I had to hurry up with those angles because I'm running towards my limit for my recording. So if x is positive, it's going to be in this quadrant. And if it's negative, it's going to be in this quadrant. So here we go. Our cosine, remember that's the same as inverse cosine of negative root 3 over 2. So for which one of the triangles is the cosine, the horizontal side, root 3 over 2? Well, that's the pi over 6. Okay, pi over 6. But it's negative. What's analogous to pi over 6 in the negative quadrant up there? 5 pi over 6. Okay. Inverse cosine of 1. Can't get that from a triangle, right? But for which one of these quadrantal angles was the cosine 1? You can look up above on the previous page. That's for the 0 degree angle, right? To get to the 0 degree angle, there's a horizontal distance of 1. Inverse cosine of 0. For which of those angles is the horizontal distance to intercept it 0? Like which one of them gives you cosine of 0? Pi over 2. Okay. Finally, tangent. Okay. So tangent looks similar to the sine. The only difference is it doesn't include these angles, so there are even less angles for you to worry about. And the angles are as follows. Right, so those are the angles, same as sine. And we've got positive angles are here, negative ones are there. So now inverse tangent of 1. So take a look at your triangles. For which angle is tangent opposite over adjacent 1? Yep, pi over 4. For which one, when you do opposite over adjacent, do you get root 3 over 3? Well, let's see. For the pi over 6, what are the sides? 1/2 root 3 over 2. Let's see, 1/2 opposite root 3 over 2 adjacent. What does that give you, guys? 1 over root 3. And if you rationalize, root 3 over 3. Oh my God, that's the one. What was the angle for that one? Pi over 6. Okay? And here we go. Those are inverse sine. All right, come see me at bonus if you guys have any more questions. Have a good day.